This video we are looking at sampling from the lecture test 3 revision package. Looking at question 5, we're told that the random variable x has the distribution binomial, 10 trials, probability of 0.15 of success for each trial. And we're asked to find the probability that the mean of a random sample of 50 observations of x is greater than 1.4. So we start by knowing that x is binomially distributed with 10 trials, probability of success 0.15. And what does that mean about x bar, the sample mean? Well, because I know the parameters for this distribution already, I can very easily find the mean and variance of this distribution. So I know that, and because I'm dealing with a large sample, so 50 observations, so because I know the original variance and I'm dealing with a large sample, I can tell you that x bar, the sample mean, will be approximately normally distributed with an average value of 1.5 and a variance of 0.0255 approximately by the central limit theorem. How did I get these numbers? Well, let me just take a minute to explain. 1.5, this is the mean. This is just going to be NP, right? So where N here is, this is N, this is P. And what about this one? Well, this is just NPQ divided by the total number of observations. So in this case, it's 50. So in this case, that would be 10 times 0.15 times 0.85, whole thing over 50, and that does indeed give us 0.0255. So what can we do with this information? Well, now we know the distribution of x bar, right? So what is the question asking us to find? It's asking us to find the probability that the mean of a random sample of 50 observations of x is greater than 1.4. In other words, it's asking us to find the probability that the mean of a random sample, i.e. x bar, is greater than 1.4 when x bar is normally distributed with a mean of 1.5 and a variance of 0.0255. So you can put this into your GC. Your lower bound, of course, will be 1.4. Your upper bound is infinity. Mean is 1.5, and standard deviation is the square root of this number. And what do you get? You get 0.7344 or 0.73423 significant figures.